Hi friends, this is Amol Sutar, and in this session I am going to talk about how to develop infrared remote control robotic car using Arduino platform. Here I am going to discuss detailed hardware design as well as software design, and this project will be very useful to uh, students from diploma and degree engineering college, those who are doing their projects based on remote control application as well as robotic applications, etc. So let us start our discussion with circuit diagram. So this is circuit diagram. It consists of three main components: TSOP sensor, Arduino board, and EL293D motor driver IC. This TSOP sensor has three main it has three pins. Pin number 1 is ground pin, pin number 2 is supply pin, and pin number 3 is output pin. A capacitor 1 microfarad is connected between pin number 2 and pin number 1. It improves range of this TSOP sensor. A small resistor 100 ohm connected between plus 5 volt supply and pin number 2. Pin number 3 is output pin. It is connected to the Arduino board, pin number 11. So this pin is input pin for this Arduino board. So it is configured as input pin. Pin number 4, 5, 6, 7. These are output pins. These pins are connected to the input pins of EL293D motor driver IC as shown in this figure. So pin number 4 goes to input 1. Pin number 5 goes to input 2. Pin number 6 is connected to input 3, pin number 10 of motor driver, and pin number 7 is connected to input 4, that is pin number 15 of motor driver. So there are two supply pins, pin number 8 and pin number 16. Pin number 8 is motor supply pin, it is connected to plus 12 volt, and pin number 16 is logic supply pin, so it is connected to 3.3 volt or plus 5 volt depending on logic supply voltage. Then pin number 4, 5, 12, 13 are ground pins, so these pins are connected to the ground. Also this motor driver has output pins, output 1, output 2, output 3, output 4. So the one motor is connected between output 1 and output 2, while other motor is connected between output 3 and output 4. The output of motor driver IC depends on input signal, and it is always in phase with the input signals. For example, if input 1 is high, then output 1 will be also high. If input 1 is 0, then output 1 will be also 0, provided this status at enable 1 pin is high. So there are two enable pins, enable 1 and enable 2. This enable 1 pins enables output on left side of this motor driver IC, while enable 2 pin enables output of motor driver IC on right side. So we can also connect these enable pins to Arduino board, and we can connect motor operation using Arduino board. We can enable, disable by sending high-low signals on these enable pins. We can even also control speed of motors by sending PWM signals to these enable 1 and enable 2 pins. So here are, we can generate PWM signals using Arduino board. There are 6 PWM pins, pin number 3, pin number 5, pin number 6, 9, 10, 11. These are PWM pins. We can use it as a general purpose IO pin as well as PWM pins. So we can connect enable 1 and enable 2 pin number 9 and 10, and we can generate PWM signal, and we can control the speed of motor. So next is motor connections. As shown in the structure, there are 4 wheels, 4 motors, 2 motors on left side, 2 motors on right side. The left side motors are connected in parallel and right side motors are connected in parallel. So this left side motor are connected in between output 1 and output 2 of motor driver. Similarly, right side motors are connected between output 3 and output 4 of motor driver. So next, this is a simple robotic car I have made in my lab for testing purpose. This is a remote control. This is Philips made remote control, and it works on RC5 based protocol. This is logic table for motor driver. So these are inputs coming from Arduino board. These are outputs. Assuming outputs are enabled, this is a logic table. The output of motor driver is always in phase with the inputs. So if all inputs are 0, outputs will be 0. If all inputs are 1, outputs will be 1. So these two extreme cases results into stop. Motor will be stopped. And other cases 0, 1, in that case output 1, output 2 will be 0, 1, and motor will rotate in reverse direction, right? Because this output 1 is connected to positive terminal of motor and output 2 is connected to negative terminal of motor. Therefore, if output 1 is 0 and output 2 is 1, in that case motor will rotate in opposite direction. If output 1 is 1 and output 2 is 0, motor will rotate in forward direction. So keeping this thing in mind, this logic table is designed and used for programming. So before writing program code, we need to follow these steps. First, download Arduino IR master library from GIT Hub. Extract that zipped folder somewhere. Then go to the folder where Arduino software is installed. Go to C drive. In that, select program files. In program file, select Arduino. Then libraries, select libraries, and in libraries select robot IR remote library. In that library, select src folder. This src folder contains header files, .h file, .cp files. So first make this folder empty. Copy all files from src and save it at some different location. Then go to Arduino IR remote master file. In that, open it and copy all files except examples. Copy all files and paste it in src folder. Okay, so we'll see these steps again. First, write Arduino IR remote master in Google and press Google search. You will get this window. Here you will get this link, GIT Hub Z3T0 Arduino IR remote infrared remote library for Arduino. Click on this link, you will get this window, GIT Hub window. So here you will find all library files, supporting files related to IR remote control. You need to download all these files. So for that, click on clone or download button, so that all these files will be downloaded in zip format in download folder. Okay, then go to the download folder, go to downloads, and in downloads, here you will find this Arduino IR remote master in zip format. Then extract this file. I have already extracted this in document folder. So here I have this file. Click on this, open it, and then copy all these files except examples. Copy all these files. Okay, and then go to the folder where Arduino installed in C drive. Go to the program files, then Arduino, go to program 86 Arduino, then libraries, go to IR remote. In IR remote, select src and paste all these files here. I have already copy pasted these files. Okay, So here we have completed those steps. Next step is how to write program. So open Arduino software. In that Arduino software, go to file menu and open examples from downloaded folder. This downloaded folder is saved in documents, Arduino IR remote master. We need not to write whole code once again. There are examples, we can use those examples to write our end application code. So in Arduino IR remote master, go to examples and out of these examples select IR record example and open it. This program code is written to record code types and code values received from the remote control and display on serial monitor. So if we see this program, see initially IR remote.h file is included. Then we know that TSOP sensor is connected to pin number 11 of Arduino board. So this pin is called receive pin. Then a button is connected to pin number 12 and a LED is connected to pin number 13. Whenever we press a remote control button, that LED will blink. Okay. Then we have different functions here. Setup function to set up parameters related to serial communication, and to set to configure pins, either input or output. So here button pin is configured as input pin and status pin, that is where LED is connected, that pin is configured as output pin. Then we have store code function. This store code function stores the code type and code value received from the remote control. So this function is very important. Then we have send code function. Okay, and then at the end we have loop function. Okay, this is a main function and the code written in this function is executed repeatedly. So we need not to bother about this code. What we are interested here is code value, the code value received from the remote control. So check where that code value is of 10. So you can see here, this is an instruction. Okay, in this instruction code value is equal to result value is written, means the final code value is stored in this variable, code value variable. So we are interested in this. The next step is save this code, give some different name and save it at some location. Okay, I have already saved it. I have given name as remote card 2. I have saved it in Arduino folder and I have modified this code as per our requirement, as per my requirement. So in this program, see this program code is similar to the